ओके ठीक है. Suppose I have the 5 processes. Process process P0 and P0, P1 and P2, P3 and P2. Okay, 5 processes are there. And suppose the arrival time for this process is 0, 2, 4, 6 and 8. And burst time is burst time. Suppose burst time is for process P0 it is 3, P1 it is 6, then P2 it is 4, P3 it is 5, and P4 it is. Okay, so suppose this is the input that you have. Now, how to apply this HHRN algorithm? Okay, so first step, as usual, draw the Gantt chart. Okay, draw the Gantt chart. So, draw the Gantt chart first. Okay, so starting. So initially, we have only one process, that is P0 at the initial level. We don't have any choice for the comparison. So execution of P0 it will start it initially. So once it is started execution, it will be complete. Execution it will complete. Okay. Remember that this is the non-preemptive algorithm. So once the process is allocated, it will completely execute it. So P0 it will start execution and it will finish at the 3. Now after 3 seconds only P1 is available. Okay, P2 is coming at the second 4 and P3, P4 after that. So only we have again only one choice. So we'll start the execution of P1. Okay, we don't have any other choice. So P1 it will get started and it will get completed after 6 seconds or after 6 minutes. So it is completed at 9 seconds. Now after 9 seconds, this P2, P3 as well as P4, all 4 processes are available. Okay, after completion of P1, that is at the time 9, all 3 processes are available for comparison. So among 3 processes, we need to choose the process for the execution. So this allocation it will be happen based on the considering the formula, that is W plus S divided by S. Okay, this is the formula. This is the formula that will be calculated, and based on this formula, the process will get allocated. So this formula is giving the response ratio. This algorithm is giving the response ratio, and the response ratio is high, that process will get the CPU. Okay, the process which response ratio will high, that process will get the CPU. So the calculation of this response time it will take place for all these 3 processes. Are you getting? So it first, suppose for process P2, we are calculating the response time for 2, that is P2. So the calculation it will be using the formula W plus S, that is waiting time plus service time. S is for stand for the service time. Service time is nothing but the bus time. Okay, service time is nothing but the bus time. So W plus S divided by S. Now what is W? W means it is the waiting time. Process how much time it is in the waiting. So considering for the P2 which arrived at time 4 and currently is the time 9, so it is waiting for 5. It is waiting for 5. So here the value of W, it is the 5 plus. Now what is the S? S is the burst time. So burst time of P2, it is 4. 5 plus 4 divided by 4. So it is 9 divided by 4, which is the 2.25. So response ratio for P2 is the 2.25. Now similarly, calculate the response time of 3, process P3. So calculate it. Again, see what is the waiting time for P3. For process P3, it arrived at 6 and now the time is 9. So process P3, it is waiting for 3 seconds plus what is the burst time for P3? It is 5 divided by 5. So 8 divided by 5, that is I think 1.6. Similarly, calculate the response ratio for P4. So what is the waiting time for P4? Since P4 it is arrived at 8, it is arrived at 8 and the current the time is 9, so waiting time it is 1 plus what is the burst time? Burst time is 2 divided by 2. So it is 3 by 2, that is 1.5. So this will be the response ratio for the time spent at 9. This is the response ratio for the time spent at 9. So at 9, this is the response ratio and we are going to choose the higher response ratio process. So process P2 will get selected for the execution since the response time is 2.25. So P2, it will start the execution. And it will start execution and once it gets allocated, since the mode is non-preemptive, so it will get finished at 30. Okay, first time is 4, so it is going to finish at 30. Now after that, at time 13, again the system will calculate the response ratio of all these two processes. Okay, since two processes are remaining, so again it is going to calculate the response time for P3 and P4. So at 13, the response time of P3, it is now formula waiting time. So first calculate waiting time for P3, arrive at 6, current time 13, so 13 minus 6, it is 7 plus
Hello, sir.
yes,
Hello.
yes,
Hello.
uh,
Sir, your screen is not visible. Probably you have to share your screen again.
network issue वगैरह. It is network issue again. So we are calculating the response ratio for P3 at a time itself. So at the time set 30, the process P3 waiting time minus 6, if we can add to 6, so 61 plus burst time for P3 is 5, so 7 plus 5 divided by 5. It is 12 by 5 That is the 2.4. 2.4 for the R4. Similarly, calculate response ratio for P4 at the time 30. So at the 30, the waiting time for P4 30 minus 8, that is 5 plus burst time is 2 divided by 2, that is 7 by 2, which is 3.5. So 3.5, and here it is 2.15, that is 2.4. So response ratio P4 is high, so P4 it will get scheduled. P4 schedule and complete at 15, and after that the remaining process, that is P3, it will get scheduled, it will get executed at time 20. Okay, so our this is our Gantt chart, that is the execution of processes in order. Okay, that is the processes in order. Now, if you compare this execution order with the SJF, so using the SJF, after that, with the SJF, if you compare 3, okay, after at 9, with the SJF, then it will focus on the first time, that is 4 and 9. In that case, definitely P4 will start with execution first. Okay. So, but here you can see the P2 will get started because although it has the greater burst time as compared to P4, but it is waiting for long time as compared to P4. So, along with the burst time, the preferences is also given to the waiting time, so that the longer jobs or the process who have the larger burst time, they will not be wait for the long time. They can be executed earlier. So that is the focus for this. That is the focus of this algorithm. That is, if the process have the larger burst time than the other process, but if it is waiting for the long time, then it can be executed first using this algorithm. So the problem of starvation, it can be limited in this case. We are not saying that completely removed. Okay, but if the process have the higher burst time, then the waiting time of that process, it can be limited by using this algorithm. Okay, so that is the motto of this algorithm. So understand how to calculate this one. Is there any confusion? Oh shit! I think screen is. Okay, problem solve
Sir,
करताना screen
again
visible
your screen is not visible, sir.
have seen. आत problem पूर्ण solve केला त्यावेळेस screen visible होती का?
Yeah, but at that time your voice is breaking continuously.
काही समजलंय का आतापर्यंत जे सांगितलंय? ओके, प्रॉब्लेम इज जेन्युइन. ब्रेकिंग होत असेल तरी प्रॉब्लेम इज जेन्युइन. पण काही सांगितलेलं कुणाला काही समजलंय का मग आतापर्यंत जे सांगितले ते? Fiza?
No, sir, I didn't understood one
Yes.
single word also because your voice is continuously breaking.
ऍक्च्युली लास्ट टाइम जेव्हा तुम्ही प्रॉब्लेम सांगितलं ना त्यावेळेस माझा व्हिडिओ मी परत स्वतः ऐकला. मला समजलं होतं की मी काय लिटरली बोलतोय ते. बिकॉज कंटिन्युअसली द साऊंड वॉज
Sir,
दॅट वॉज द केस. सो प्रॉब्लेम इज जेन्युइन बट प्रॉब्लेम इज कम टू मी. ओके सो
नाही ते आता नेटवर्क
हां ते नेटवर्क इश्यू आहे. दोन्ही साईड क्लिअर आहेत. मी पण जास्त काही करू शकत नाही कारण लास्ट टाइम मी 3 ते 4 वेळा जागा बदलली होती. लिटरली मी लास्ट टाइम टेरिसवर जाऊन बसलो पण तिथं पण वाऱ्याचा आवाज भरपूर होता त्यामुळे परत मला खाली यावं लागलं होतं. ओके सो प्रॉब्लेम इज जेन्युइन फ्रॉम ॲट बोथ साईड.
Why don't you rejoin?
एक मिनिट हा. मी फायनल टाइम ट्राय करतो स्क्रीन शेअर करायचा बट स्क्रीन जरी शेअर केली साऊंड जर क्लिअर नसेल तर मग आय थिंक देर इज अ प्रॉब्लेम. स्क्रीन जरी शेअर केली आणि जर साऊंडच क्लिअर नसेल तर तुम्हाला समजणार काय. Okay, so this will be the final time for the rejoining as well as for the sound place changing. प्लेस पण चेंज केली. जर सपोज नाही हे झालं तर मग आपण लेक्चर स्टॉप करूया. प्रेझेंट घेतो आणि ट्राय करतो की दुपारी जर कॉलेज ओपन असेल तर तिथं जाऊन लेक्चर घेतो. ठीक आहे. सो इज माय व्हॉइस क्लिअर? एम आय ऑडिबल नाऊ?
Yes, sir.
ओके सो एकदा परत रिपीट करतो शॉर्टमध्ये. इन द HHRL अल्गोरिथम आपण फोकस करतोय दोन गोष्टीवर. एक आहे तुमचं वेटिंग टाइम, प्रोसेसचं वेटिंग टाइम ॲज वेल एज प्रोसेसचा बस टाइम. SGF अल्गोरिथममध्ये ह्या अल्गोरिथम कंपेरिजन आपण SGF सोबत करतोय कारण की SGFच हे आपण मॉडिफाईड व्हर्जन म्हणू शकतो. बिकॉज इन द SGF वी आर फोकसिंग ऑन द बस टाइम. शॉर्टर द बस टाइम the process will get selected. So here we are considering both parameters, bus time as well as the waiting time. Process चा bus time जरी short असला तरी पण जर ती प्रोसेस शॉर्टर टाइम साठी वेट करत असेल, ओके हिअर आय एम फोकसिंग द शॉर्टर वेटिंग टाइम, तर त्या केसमध्ये ज्या प्रोसेसचा बस टाइम थोडासा जास्त असेल पण प्रोसेस टाइम ह्यूज असेल तर त्या केसमध्ये ती प्रोसेस आधी एक्झिक्यूट होईल. द फॉर्म्युला इज W plus S divided by S. So W stands for waiting time and S stands for service time. Nothing but your bus time. So by using that formula, every time the response time is calculated, and the response time, the higher the response time, the process will get allocated. Okay, so that is the scenario. So using that, here we are considering the formula. So process P0, it is starting get executed. Sorry. So process P0, initially only one process is there, so it will get started for the execution. Completed execution, since the scenario is the non-preemptive, mode is the non-preemptive. So at the end of 3 seconds, only P1 is available. So again, we don't have any choice. So P1, it will get start execution. So at the end of 9, where the P1 is finishes, then we have the three processes, process P2, P3 and P4. Now, since we have the three processes, we can apply the formula. We can calculate the response ratio. So calculate the response ratio for process P2. So apply the formula at the time 9. At the time 9, P2 waiting time 9 minus 4, so waiting time 5 plus burst time, that is service time 4. So 5 plus 4 divided by 4. So you will get 9 by 4, that is nothing but the 2.25. That is the response ratio of P2. Similarly, calculate response ratio for P3. So it is, first take the waiting time 9 minus 4, sorry 9 minus 6, it is 3. So 3 plus burst time 5, 3 plus 5 divided by 5, 8 by 5, that is equal to 1.6. Similarly, response ratio of P4, that is 9 minus 8, that is 1 plus 2 divided by 2, so 3 by 2, that is nothing but 1.5. So 2.25, 1.6 and 1.5. So the response ratio is higher for P2. So P2, it will start its execution. So P2, it will start execution and it will complete at 13. So again at time 13, the response ratio for P4 and P3, again it will get calculated, and we have seen the response ratio of P4 is higher. So P4, it will start execution, and after that P3. So that was the Gantt chart. And we have compared this HHRN with SJF. If you apply SJF non-preemptive for the similar example, then you can see that for P4, then you can see that for this algorithm using the SJF non-preemptive, process P0, it will get started initially, and after that only P1 is there. Again P1, it will get execution, and after P1, at the end of execution of P1, that is at the 9th second, all three processes are available, and if you apply SJF non-preemptive on these three processes, then you can see that process P4 has the shortest burst time. So using SJF non-preemptive, process P4 will get allocated for the execution. But here in the HHRN, so here clearly you can see along with the burst time, if you apply the waiting time, then you may get the different reason. You may get the different order of execution. So that is the point that you have to see. If you see in SJF only, since we are focusing on only burst time, then the order that you get, that may be a different if you consider in the case of HHRN, where the focus was burst time as well as on the waiting time. Okay, so जर आपण बस टाइम आणि वेटिंग टाइम दोन्ही जर कन्सिडर केलं तर त्या केसमध्ये SJF नॉन प्रिम्प्टिव्ह पेक्षा सिनारिओ वेगळा येऊ शकतो. SJF नॉन प्रिम्प्टिव्ह मध्ये आपण फक्त आणि फक्त बस टाइमला फोकस करतोय, त्यामुळं अशी प्रोसेस ज्याचा बस टाइम स्लाइटली जास्त असेल बट प्रोसेस ही जास्त वेळसाठी वेटिंग करत असेल, तर त्या केसमध्ये डेफिनेटली त्या प्रोसेसला आधी एक्झिक्युशन व्हायला पाहिजे. ओके, प्रोसेस हॅव्हिंग slightly greater burst time, but if the process is waiting for the longer duration, then that process must be executed first. But that is not happening in the SJF. So this algorithm is provide that facility. Okay, this algorithm is using this algorithm you can do that. So this is the I think this is the modified. Okay, this is the modified version in case of SJF. Again, practically this is not possible. Okay, likewise in SJF, it is also practically not possible. And similarly, this algorithm is practically, right now, practically it is not possible. When I am saying practically not possible, my concern is with respect to the short-term scheduler. Okay, I am talking about the short-term scheduler. I am not talking about the long-term scheduler. If you consider the case of long-term scheduler, it might be a possible. Okay, थोड़ा विचार केला, you can understand. If you concern with the long-term scheduler, you can say that it might be a possible. But here my focus is on the short-term scheduler. So from the perspective of short-term scheduler, both scenario, that is SJF as well as HHRL, both scenario it is not possible right now. Okay, आता तरी हे दोन्ही अल्गोरिथम हे पॉसिबल नाही आहे प्रॅक्टिकली, जर आपण फोकस केलं शॉर्ट टर्म शेड्यूलरच्या केसमध्ये. ओके, सो दिस बोथ अल्गोरिथम इज still not practically possible, but we have to consider the algorithm. Okay, so असं पण एक वे आहे की ज्या वेळी आपण प्रोसेस अलोकेशन करू शकतो. आतापर्यंत आपला जो फोकस आहे, ओके, हे सगळे अल्गोरिथम जे आपण आतापर्यंत स्टडी केले प्रोसेस अलोकेशनचे, हे सगळे अल्गोरिथम आपण कुठला ना कुठला पॅरामीटर यूज करून अलोकेशन करतोय. फॉर एक्झाम्पल एफसीएफएस मध्ये आपण अलोकेशन केलं ऑन द बेसिस ऑफ अरायवल टाइम, not arrive हो, yes, on the basis of arrival time. The process that will be arrive first, that will be execute first. So in that case we are considering the case of arrival time. त्या बेसिसवर आपण प्रोसेसचं अलोकेशन करतो. सिमिलरली एसजीएफ मध्ये अलोकेशन कोणत्या बेसिसवर होते, ज्या प्रोसेसचा बस टाइम हा सगळ्यात कमी असेल, शॉर्ट असेल, त्या बेसिसवर आपण अलोकेशन करतो. सिमिलरली प्रायोरिटीमध्ये अलोकेशन कोणत्या बेसिसवर होते, the process having the higher priority. ज्या प्रोसेसची प्रायोरिटी हाय असेल त्या प्रोसेसला आपण आधी एक्झिक्यूट करतो. म्हणजे की तुम्हाला प्रोसेस एक्झिक्यूट करायची नो डाऊट, पण ती प्रोसेस एक्झिक्यूट करायला आपल्याला कोणता ना कोणता बेस पाहिजे. त्या बेसवर आपण ती प्रोसेस अलोकेशन स्टार्ट करतोय. ओके, सो लाइकवाइज वी हॅव द राउंड रॉबिन, where on the basis of time slice, okay, here we are considering the both cases, time slice as well as FCFS. So by providing both two parameters we are performing the execution. And again this is HRRN, in which again we are considering the both parameters, that is the waiting time as well as burst time. So you can see that by applying the different parameter we are trying to execute the process for getting the better performance. आता सध्या जर आपण सिनेरिओ बघितला तर मोस्ट ऑफ द ऑपरेटिंग सिस्टम दे आर युजिंग द राउंड रॉबिन. ओके, अगेन यू कॅन consider if you go for that, again in the round robin there is a case of CFS, that is the completely fair scheduling, जे की आपल्या सिलेबसचा पार्ट नाही आहे, but roughly मी एक आयडिया दिली होती. So again in the current operating system they all are implementing the round robin with CFS. Okay, CFS मध्ये आपण round robin consider करते, so roughly you can consider round robin. So in current scenario, in the current OS they are using the round robin. And if you consider the case of real time operating system, ज्या की सॅटेलाइटच्या केसमध्ये असतील किंवा मेडिकलच्या केसमध्ये असतील, जसे की तुमच्या मेनली किंवा रोबोटिक्सच्या केसमध्ये, जसे की OS यूज केलेला तुमच्या रिअल टाइम OS, तर त्या केसमध्ये प्रायोरिटी शेड्यूलिंग आपण यूज करतो. सो पॉइंट इज दॅट की डिफरंट शेड्यूलिंग अल्गोरिथम वी कॅन डिझाइन. सो इफ यू हॅव द बेटर न्यू आयडिया, आतापर्यंत आपण तुम्ही डिफरंट आयडिया बघितल्यात ज्या बेसवर तुम्ही प्रोसेस सिलेक्ट करू शकता. It may be based on SCFS, it may be based on SGF, it may be based on priority. These are the parameters that you have. So likewise, you can think the other parameters also. For example, SGF, SGF, that is shortest burst time. Likewise, you can think longest burst time, and you can check the result. Okay, definitely the result will be the higher better, higher. What do you guys say? Higher turnaround time. Okay, so likewise, try some another way, try some another parameter based on that, or try to combine this parameter. So based on that, you can get the better result. Okay, that's why that I want to say. You can also try for the other parameter also. That is dependent on. Okay, so am I audible clearly? Am I audible?
Yes, sir.
इंटरप्शन काय होते का समजलं सगळ्यांना okay all of you get understood this example okay then calculate completion time turnaround time and waiting time for this example okay first try to understand this take reference but try to solve your own only take the parameter that is the arrival time and burst time and try to solve your own that is try to draw the Gantt chart your own calculate response time for the reference you can see this but try your own and calculate turnaround time waiting time as well as response time. Okay, give me attendance for division A, roll number 1. Two,
Present, sir.
3,
Present, sir.
4, 5, 6,
Present, sir.
roll number 7,
Present, sir.